Hello and welcome to Identity Office Hours. I'm your host, Mike Schwartz, founder of Glue. Today is episode 175. The title is Secrets Leak. Why do we have secrets? Our guest today is Dwayne McDaniel, Principal Developer Advocate at GitGuardian. Welcome, Dwayne.
Thanks so much for having me. I'm very excited to be here and very glad to be part of this show. This is an awesome show I've been watching for a minute, so getting to be a guest is a special treat.
So before we dive into the topic, maybe you could tell us a little bit about your background.
Sure. Background's kind of all over the place, but the short version is I started life in sales, tech sales. I went to school for computer science. Didn't do anything with it, realized, hey, I can talk about this stuff. So I fell into the world of enterprise middleware and Java back 20 some years ago. And then just proceeded from there. Went through a few Silicon Valley jobs. Really loved getting into leading edge and bleeding edge technology. Loved open source from the first moment I was exposed to it. Ended up working eventually for a company that did DevOps as a platform for websites. So WebOps is what we shorthand referred to it as. But that was a company called Pantheon. And while I was there, a very smart VP of sales said, "You're really good at explaining things, but I need a closer that's a little bit more aggressive than you for this particular role. But you're good at explaining things. Why don't you help people figure stuff out?" And that literally changed my life because I say that as my entire mission in life. Those 5 simple words: help people figure stuff out. If I'm doing that, I think I'm doing my job. And for the better part of the last 12 years, that is exactly what I've been doing. And now I work in the world of security. I work for GitGuardian. I'm very grateful to be here for 3.5 years. I've learned so much along the way. And now I'm on this crusade to get people to stop using long-lived credentials and move toward other forms of authentication so we can stop leaking secrets.
Right, which is a good segue back to the topic. But I want to dive in the deep end right away with the attack. So, because I think the attack helps us understand really some of the challenge. So what is the Shai-Hulud attack and what did we learn from it? And Shai-Hulud is Shai and Hulud. And the Shai-Hulud, I guess, is from a Dune reference to the big giant sandworm.
The sandworms are referred to by the Fremen as the Shai-Hulud. I am a huge Dune nerd. I think God Emperor of Dune, the 4th book, is the best book. You got to be a real nerd to get to it. But it's got my favorite line in all of Dune. They're talking about why did they destroy the thinking machines? Because what do such machines do? They let people do things without thinking. People doing things without thinking, there's the real danger. That's kind of the heart and soul of the book. But anyway, Shai-Hulud is a worm, and Shai-Hulud, the attack, is a worm. It's a self-replicating attack, and this is part of what makes it scary. Last year, the attack immediately before that in the supply chain world, this is a supply chain attack, was called Singularity with a one instead of the I in Singularity. And that used prompt injection through the NX ecosystem to tell the local bot to spit out all the credentials and double base 64 encode them and then push them onto GitHub using the stolen credentials. Mildly successful, but it proved it was a proof of concept. And then we saw it come back, but as a self-replicating worm where it infects a package, abuses certain things. I'm not going to get into the finer details of supply chain attack for a wider audience, but abuses some of the processes around publishing NPM packages and literally does the same thing. Uses tools to find environment variables, secrets, credentials of any form, and then push those into some kind of public place where they can be harvested, and also replicate yourself into any supply chains it can figure out how to replicate itself into. There have been 2 major waves of it in 2025, and we're right in the middle of the 3rd one right now. It's mutating. It's actually mutated in a way I didn't expect because it's starting to cross over and bleed with the OpenClaw ecosystem. in some very interesting ways. In fact, that's the other big supply chain attack that's got me a little rattled right now is the Trivy GitHub star thing. Trivy, which is I think the most downloaded vulnerability scanner in the world, their GitHub repo got compromised by a similar attack, except instead of just stealing credentials and just replicating itself, it actually wiped all their GitHub stars. So as of right now, Trivy on their GitHub only has like 300 stars when they had 32,000 yesterday or 2 days ago, whenever the attack first started or actually executed.
It's years of marketing down the road,
That was
down the in the garbage can. Unless they can get GitHub to restore them, that's a huge hit to the brand, because how many conferences and talks did they have to do to get 32,000 stars on GitHub?
But that's the beautiful part. Not beautiful part. I think I like an attacker way too much, because the clever part, that was a giant distraction from what they actually did, which was to push out malicious code into the VSLX, whatever the what do you call the thing? The text editor, VS Code, the VS Code ecosystem. So it's VSLX. That ecosystem of extensions, that's what the attack actually ended up doing, was pushing Trivy-backed extensions and updates that had malicious code in it. And the outcome of that, we're talking something today's the 3rd of March. This happened on the 1st. So that's how fast this is evolving. But it's this idea of, can we get into the ecosystem? And there's many ways in, but the way that it's actually happening, not theoretically, is credential theft, credential abuse. It's broken access control is still number one on OWASP for a reason, because we keep making it easy to just walk in if you find a key.
So I wanted to take a step back and ask, like, what do these NHIs look like? What do these shared secrets look like? Are they API keys, tokens, certificates? You mentioned environment variables in memory. So what's sort of the range of, like, what do these secrets look like in the real world?
One of the downsides of referring to them as NHIs, and Gartner's admitted this, is like where the term non-human identity came from, was a Gartner report from a few years ago, and then OWASP adopted the terminology, and it's gotten us to this world of, like, if it's not a human, it's a non-human. But that also means, like, tables and chairs and cows and aliens from outer space. Like, a planet Earth is technically not a human. Is it addressable? Yeah, that penguin. Perfect. But that's not what we really are talking about. We're talking about machine identities, and most often we're talking about workload identity. I really like the term workload. It comes from, of course, the CNCF originally, because Kubernetes it thinks in terms of workloads. But the IETF actually has a really good working definition right now. It's a running piece of software. It's running to accomplish something. I'm paraphrasing heavily.
Right. Well, at that point, why don't you just call it software identity? If the definition of a workload is a running piece of software, why not just call it software identity?
I didn't name any of this stuff, Mike. I wish we would have. It would have saved everyone.
I'm using software identity myself.
If we say,
because I think it ultimately is almost always a piece of software we're talking about. Even if it's hardware, it's a piece of software running in the hardware that needs the identity and would interact with systems. So, I was on the workload bandwagon for a little while, but I think workload is very cloud oriented. Mm-hmm. It really makes sense when we're talking about cloud workloads. But when you're talking about mobile devices or processes running in the browser, I don't think about something running in my browser as a workload or a mobile app as a workload. So I think in that case, software is a better fit. This is just my 2 cents.
That's completely valid. I think we're both agreed that non-human identity is a very, very, very wide bucket.
But it's infinite bucket, actually. The list of what's not human is infinite.
Yep, it's proving a negative. That's the ultimate problem. There's a follow-up article from someone at Gartner who admits that. Like, yeah, we made a bucket that was the null set.
Yeah. So I really should have just said secrets, though, right? So let me rephrase the question. Um, the distribution of these secrets is a problem.
Mm-hmm.
And what what types of secrets are these,
Yeah.
and what types of forms do they take before they're stolen?
Uh, Basically, it's anything that access granting is readable and usable. But readable doesn't necessarily mean by a human. Uh, Readable and usable in any capacity. The classic examples we think of are API keys. Uh, we're talking about database password URLs, database connection strings that include the password inside of the string. Like your calls to GitHub that have a username password in it. Uh, Certificates, anything that is a piece of data. I really like the definition from what's the name of it? Teleport. It says it's
Consovoy?
yeah. It's a piece of data that is somehow used for access. That kind of sums it up. If it's readable, if it's processable, if it's stealable, that's what we're referring to as general bucket of secrets. Now, when you get down to the
By the way, I just want to hassle you here for 1 second. Certificates can be a one-factor authentication credential, used like a one-factor authentication credential.
Mhm.
But if I present my smart card, for example, I need to provide a PIN number to unlock it in order to make it two-factor to add the second factor. But you're right, I agree with you. If a certificate is presented as the only factor for authentication, it is basically a secret file.
Mm-hmm. Yeah, exactly. That literally was going to be my point. If we're talking about finer details of what certificate actually means and what API key technical definitions, yeah, there's a little bit of praise in there.
My cat is wreaking havoc. That's what happened. She's knocking stuff over. She's like, let's knock over the cup. That will annoy him. Sorry for the interruption.
Wanted to get on the mix. That's great. But that's my finer point is we can split hairs on what is or isn't a secret. I am more concerned of, does it exist? Do you have an access mechanism for anything that I can access without proving who I am and supplying like the reason I'm there? The way I like to think is just general keys. I've been thinking this for years, because someone shows up at your front door with a key to your house and they just walk in, like, well, you had a key, take what you want. Versus someone comes up to your door and your Ring doorbell or whatever system alerts you, like, someone's there, and you say, hey, who are you? Like, oh, you ordered this from my company. I am here to deliver it to you. It's like, oh, yes, I verify that. I will open the door temporarily to receive this one package. It's a put, not a get. And we all agree to this, and open the door, and the transactions, and everybody's happy. And they got a one-time temporary access based on who they were, why they were there. We all agreed on those factors. Secrets are I had a key and could walk in. That's the analogy I always use.
Yeah, impersonation is really problematic because we can't, if you give your key to somebody, then we can't tell the difference between the person who originally possessed it and the person who possessed it for the presentation. Mm-hmm. So I agree with that. But one of the things that you said that was kind of terrifying was environment variables in memory. Mm-hmm. So a lot of, maybe a token might be injected, even a short-lived token. So there are OAuth best practices which say that, we need to have to use tokens for a period of time, but we want them to be short-lived. So are you saying that the use of tokens at large is problematic and should be avoided? And any type of token, whether it's let's say a token that will be traded for access, or a JWT, either a value token or a access token, let's say. Are you saying the tokens are just off limits because they're ultimately secrets?
Well, I mean, that's not get to a level of absurdity. We still need some way to agree on the cryptographic handshake to make MTLS happen. At some point, you have to exchange a very long string of numbers or characters to do that. So at some point, yeah, there needs to be something there. I've had this conversation a number of times with some of my colleagues here at Git Guardian. But you trusting a single point with a single factor for authentication is never a good idea. So if that token can be like grabbed and reused within, let's say, a minute and a half, for a human, that's a ridiculously small amount of time to figure out what you're doing. But we don't live in a world where machines are where humans are the ones figuring out how to abuse these things. And now with attacks, especially in agentic AI land, it can be milliseconds from the time it's like, this looks like a key. Let me go try to verify this. And if it works, automatically inject the prompt, automatically inject whatever I want to inject there. And that's the problem we're up against now. There always will need to be a way to prove the authentication, but the problem, to answer your question, is not the token itself, it's the standing privilege the token allows. That's the cryptographic, or that's the authentication failure. We're saying you as an entity, for whatever reason, have standing privilege, and we're hoping that we shrunk the window down where that standing privilege exists to this amount of time, versus the conversations ongoing right now out in DevOps land is, can we move that transaction boundary, or can we move the authentication request itself to the transaction boundary, and the token only exists within the context of the handshake that's going on. And then the standing privilege only exists while that transaction, only that transaction goes on. So if it's stolen, tried to be reused, like, wait a minute, this isn't the transaction this was approved for. It doesn't work. That's where I see this going. Will there still be a token? Yeah, of course. There's going to be a handshake. You got to have something you handshake with. It's the idea that the token would ever provide standing privilege. This is the tenets of zero trust. We have to get to a point where there's no way to do anything unless it's re-verified. Which
actually, I don't want to go there yet because you're sort of going into the policy domain. What is the meaning of the token? But I'm still like stuck in the identity part. So if we one of the strategies that we can use if we don't and if we don't want to rely on a replayable token is to cryptographically bind the token to a key that's only accessible in a hardware key store, so that nobody could present the token without possessing this corresponding key. And if you can store that corresponding key in a safe place, like a key store in a mobile phone, or I guess a trusted certificate environment on the hardware, then technically, even if the key was stolen, it wouldn't be usable without the proof. So are you saying that basically that's sort of the direction we need to go, is that we need to have this level of like token binding, let's say, to really be able to trust the tokens?
That totally works for human identity. What you just described, hardware-based security for passkeys. I definitely see that for going for human identity, absolutely. But thinking of machine identity, I don't know. The whole point, the whole problem, or part of the whole problem, there's a lot of parts of the problem, but one of the parts of the problem is you can't MFA a machine. Machine either gets in or it doesn't. You can prove its identity and factors around that identity. Like that's a philosophical question I heard last week when I was at Confu up in Canada, is like, does your identity include your location?
Right. Actually, I have a thought about this. We don't need to 2FA machines. Actually, there is a human cyber divide, which is uncrossable. Until we put USB inputs into our biology, there will be this divide, and the only way we can get over that human cyber divide is with two-factor authentication. However, machines or software is already in cyberland, and therefore we can rely on cryptographic authentication to authenticate a machine. We don't need two-factor to authenticate software.
I think the proofs are different, but it's multi-factor. Otherwise, we're back to I have the key, I can get in. The machine doesn't know who's using the key.
Okay, so we could have a policy about access that does not strictly rely on the identity asserted by the machine. Ultimately, the software, as you pointed out with regard to access, the identity of the software, the NHI, is only needed for accountability. Because when something goes wrong, we need to blame somebody. So I need to know what human, what piece of software, which MCP server, which API gateway, which database. So I need to be able to identify all the different pieces of software. And for that, I need identifiers that are cryptographically bound and can be trusted. But from a policy perspective, whether I allow access to a certain piece of software, I would think that it would depend upon the claims associated with that identity. And those could be claims about a human or a piece of software. Or contextual, like time of day, network address, those types of factors. So maybe we're arguing over semantics, but I think in terms of proving identity, as long as we can do an asymmetric authentication, that's enough.
Yeah.
But with regard to access or to data systems or information, I think for there we're in a multi-policy, like multi-trust environment. So you think that's what we're aligned on?
Multi-trust environments. It all comes down to where you architected the trust boundaries. And that's the ultimate thing between machines and humans. Humans have to have an interface. There's a terminal. Like to quote Neil Stephenson, like all we're doing is writing little notes to our computer. That's all we do. That's what the command line does. And GUIs just wrap that. Machines don't need that love letters. They can communicate in other ways. And maybe ultimately abstracted out, it is the same thing. But I just feel like need to treat it a little bit differently. I don't feel like human identity and NHI can be solved with the same policy engine.
Well, let's maybe pivot off the esoteric. I'm inclined to want to solve the whole problem architecturally and just get rid of this problem. But for the foreseeable future, we're going to have secrets. We're going to have APIs that have tokens, certificate authentication, and all sorts of other secrets. So I'm an enterprise and I want to mitigate this risk. What do I do? How do I even know how extensive the problem is at my organization?
This is a straightforward technical question, and I appreciate that, man. The reality on the ground is, like, no matter how esoteric and like creative we can get with possibilities, if a developer wants to connect workload 1 to resource 2, they're most likely going to use a long-lived API key. That's the actual reality on the ground. This is part of the jungle of acronyms that you go through when you're learning IAM. Is like, these are all great ideas. Why haven't we implemented these? Oh, because the developer, it was way faster to just do it the other way, the unsafe way, the way that's traditionally we've been doing it for years. But that leaves a trail that if there is a piece of data that you're using for access, For authentication, you can track that. You can track your data. Data is trackable. It's findable. That's literally what we do at GitGuardian. That is our entire MO, is find secrets where they are and describe the state of them. We started life is just looking at GitHub public and just looked at code. That's why Git is in the name of our company, Git Guardian. Looking at public GitHub, every commit, we still do this to this day. Every commit that hits GitHub in public, we scan it for a secret. And if we find a secret, we email you right then and there and say, you've done this, being the committer of that commit, the author of that commit. And we send out millions of these a year and say, hey, you've done this in public. Don't. A link to our product, obviously, in there somewhere. But then that, we realize you can hook that engine up to any internal repos. But wait a minute, why are we stopping at internal repos? It's just text at the end of the day. Like the beauty of Git is just text all the way down. Very, very, very well stored, but that's all it is, like just blobs all the way down. So why can't you just hook up everything that's got data to that, and even including the developer machine? Like, let's start scanning across all your environments, your CI/CD pipeline, your repos. Is there a secret in there? This goes back to, what is the definition of secret? Well, we're saying it's a generic term or access mechanism, credential of some form that's identifiable, that's actually usable, not conceptually just a high entropy string. Is it contextually doing anything? Is that high entropy string being used as a bearer token in an API call, for instance, just for one of it? Or is it a high entropy string that describes like just the developer being frustrated and yelling at the machine in a comment? That's harmless. Like, yeah, just jamming on the keyboard. I do that occasionally. I don't commit those. I try not to, but sometimes I get frustrated. So the observability problem is solvable in the short term with technology. There are many players on the market. I think our solution's the best tuned for enterprise out there. It's not just, does it match a pattern? It is contextually, is this string being used, this high entropy string being used to grant access? So that's step one of how we get out of this mess of secret leaks. So when I wanted to call this episode, or asked you to call this episode, why do we even have secrets? I think in pragmatic terms, how can we get away from the answer to that question is, why do we have secrets? Like, you probably shouldn't. How do we get away from them is the next logical question to me. And that's step one. It's like, let's take an inventory of all the secrets where they are, wherever they are, whether that's in plain text somewhere, and now inside the vaults, inside of your secret manager. We can connect to those, connect to identity platforms, we can connect to, again, it's text. It is something in there that is text that we can make memory dump out, say, this is a string, cache that, take a fingerprint of it, and now we have an inventory across everything you have. More stuff getting added.
Are you trying to put yourself out of business? Because it sounds to me like you're saying, we're going to give you this list of secrets, and really your mission should be to eliminate this list down to zero. So if you do your job, shouldn't you put yourself out of business?
I mean, horses still exist, man, but we're all driving cars. Like, in the long tail, absolutely. But in the long tail, like, the idea that we'll have jobs at all is kind of weird. In the long end of it, like, yeah, sure. But I'm also not worried about Fortune 2000s stopping using API keys in the next rest of my life. I'm just not. We've been doing it for 40 years, and we're going to keep doing it for another 40 probably.
Do you think that this is like a tooling problem? Is it a DevOps velocity problem? Is it a governance design flaw? Like, why are we in this situation if we know that secrets need to be managed, carefully? Why are we in this mess?
It's a little bit of all three of those and some other stuff. The way I always explain to my friends, my non-technical friends, is we made a decision at some point that, hey, passwords were good enough for humans to see who accessed the system. It wasn't to keep people out. I'm thoroughly convinced that passwords originally got just who could we charge the machine time to for the kids that came in late night in the 70s to play Zork or Adventure or whatever, Space Command, whatever game they were playing on those giant Unix boxes. And we said, well, if that works for humans and we can track access and grant access through these keys, why don't we just do that for a machine? Like, let's make it really long. And then who could guess that? Because it's be a really long string. And it's like everything else on the internet, it's the first thing that worked. Okay, that works. And then we just kept doing it. It didn't become a serious problem until the age of cloud computing. And it's only accelerated at a massive rate in the last 8 to 10 years. I mean, think about 20 years ago. If you wanted to deploy a service online, you got to buy a server. There is so much setup to get to that physical server. You got to go into a room. How can you also access that server? Oh, that's really hard to do. Even the people that work inside the company are going to have a struggle connecting to your server. That's like why web methods came about. And we're talking the days pre-API key or pre-APIs. Then APIs evolved. And the number of services, somebody told me back in November that there are 38,000 SaaS offerings that have possible API keys. I don't know if that's a true number, but that's the number said. That sounds like the right scale, plus all the homegrown stuff. And now we're deploying code faster than ever. You can go look at the GitHub State of the Octoverse from October. More developers now than ever. We're pushing more code. We did almost twice as many pull requests closed in 2025 than the previous year. It's like maybe not twice as much, but it's a giant step up, maybe 53% jump. So 1.5x. And what are these pull requests? What are we doing? We're deploying more and more complicated, larger scale systems that have not just 3 things tools are connected to, but it's thousands of workers, thousands of workloads connecting to hundreds or thousands of services to deliver an experience that hopefully shows up well in the front. So yeah, to answer the question, it's all of them. It was the first thing that worked, and we kept doing it, and then the scale got out of hand, and now it's like, who do we blame? Do we blame the developer for not doing it the right way? Do we blame DevOps for keeping this thing running? Well, do we blame the CISO for not putting their foot down and saying we're stopping all production? They would get fired for that. Is it the executive's fault? Is it IAM's fault for not stepping up sooner and saying they wanted control of non-human identities before non-human identity, the concept came around? Like, yeah, it's everybody kind of failed here, but we're not going to solve anything if we point fingers and say, this was a failure on your part. We're going to solve this if we get together and say, what does the future look like, and how do we architect that to make that the easier path than what we're doing now? And that's my great hope for security engineering.
Yeah. I mean, at a certain point, Harry Truman said the buck stops here. If something's broke at the company, it's the CEO's fault. And so fundamentally, it seems like this challenge is an executive governance challenge. Like, nobody said that there needs to be, that we shouldn't do this, and therefore the developers are taking the path of least resistance to deliver on their probably overly aggressive, timelines for shipping new code. So ultimately, though, I think it's a governance challenge for not setting the right rules of the game. I guess, and I know GitGuardian has a governance platform. So I guess my first question on this would be like, how do you define governance? Like, what does good governance look like, and how do you measure it from a secrets management perspective?
So I'm going to answer that question, I promise. But to get there, given where we came from, the observability play of like, let's find all the secrets. Let's give you a visual visibility into all of these secrets. The next logical question on that was like, what state are they in? And to call it NHI state observability management was kind of a mouthful and weird. And then that raised more questions than it answered. So governance, we went with in part because it's a shortened term to say, what state should things be in, and how can you prove that they are in or out of that state? That's what we mean by governance. Not an enforceable state where we prevent anyone from deploying things. It is the observability around, hey, this is outside of the policy. And the policies we started with were the NHI top 10 from OWASP. And that's still a maturing product. Is that really like all other software? We're still building that out. So enforceability is not our focus. Our focus is remediation. Like, how do you go from a state you don't want to be in to a state you want to be in with it?
That's a very interesting definition. I like it. So, what's our ideal state? What state are we in? And then what's our plan for sort of getting into a better state? And looking in the specific vector of secrets management. So interesting. What do you see as some of the challenges? As we talk about agentic, I feel like, in every episode, and agentic perhaps is really pushing this to board level visibility, where I believe that the business leaders are really hearing on podcasts that agentic's going to change the world, and they have to invest in agentic. And agentic, of course, is a software identity, a piece of software doing, taking actions, generating value, answering customers' questions. And so how do you see agentic sort of changing the landscape in the next couple of months?
We had a really good conversation about this back at KubeCon. Actually did an event right before that with CyberArk, their identity day zero. Not 0 day, day zero. I'm getting grief about that. It's like, you gave a 0 day event. I'm like, no, it's day zero. And that was what a lot of us walked away with. Like, practitioners and suppliers out there, or vendors out in the world, had this conversation of like, are we taking it more seriously now because agentic is driving it to a front seat conversation? If you 2 years ago tried to have a conversation with a senior level executive about non-human identities and how your workloads connected together, eyes would glaze over and they'd have no interest in having that conversation. It's like, yeah, the machine works. Now, because I think it's partly because we started calling things like Claude and Cursor, and we gave it, like, we're anthropomorphizing the identity of these agents. And so, of course, we have to give it an identity. Of course, we have to treat it as if it's a person. I hold maybe not the popular belief, but there's nothing really new with agentic AI. Like, you let scripts do stuff for a long time. We've automation. It's just a faster way to do automation with a recursive loop of a probabilistic engine. Like, that's what OpenClaw is. Like, the beauty of OpenClaw is the router in the middle. Like, everything just routes back through itself, and it's a beautiful system. But at the same time, it's like, what's routing through there? Oh, a request from a thing. What's that thing? It's not a human. It's a running piece of software doing something. And now we're right back to the conversation that we've been having for a long time. How do you grant access to the systems it's trying to address? I do think it's definitely sped up the conversation. And the evidence was that beyond that event we did with CyberArk, like the very next day, the opening keynote in the opening keynotes at KubeCon, Spiffy and Spire are now front row citizens. When people talk about agentic AI and like AI security in general, cloud native folks this is how this works now. Like, we're going to move into Spiffy IDs for everything, and we're going to use Spire as our inspiration for how all of these transaction MTLS handshakes work from here on out. I think this is actually one of the talks I just gave up in Kung is we're slightly misunderstanding what the machine is and where the guardrails can go, and it's not just a black box that's spitting out the end product. If you're building an agentic system, there is that black box that you can't see how the LLM is doing the math and how it's doing vectorization and matching, but you can look at the rest of the architecture. And if you start looking at architecture diagrams, they're going to look real familiar real fast because it's web architecture. It's literally web apps. I'm not scared of a web app. I'm scared of someone abusing a web app. I'm scared of if I give someone unauthorized access to that web app, what can happen? But that's now like the access is given to this probability engine inside of it. But at the end of the day, it's just a web app. Again, that might not be the most popular opinion out there in the world, but that's where I see us. I think we're having the bigger conversation around identity with non-human identities and authentication because of agentic, but not because agentic's bringing something brand new to the table.
So you mentioned Spiffy, and so Spiffy provides a way to get an identifier and also a certificate. So we can assert an identity and we can prove it, but it doesn't provide any claims about the software. And a lot of the challenges we have are, what are the provable, what type of agent is this? What organization is this piece of software associated with? What's the business unit that wrote this software? What's the human that the software is acting on? What are the what APIs is this piece of software allowed to call, or what actions is this allowed to do in the MCP server? Mm-hmm. So the claims about the software is really what we're struggling with. How do you see the evolution of infrastructure where we can actually manage not just the identity of the software, but also some of the claims?
This is one of the places where I think jamming together identity and access management together as one thing was kind of a misstep, because we also, as a side effect of that, jam together the concepts of authorization and authentication, which are two completely separate concepts, as you just pointed out. Like, proving the identity of something doesn't give you the claims list, and this goes back to standing privilege, and it shouldn't. It should just say, hey, you should be here. You can enter into the conversation about what we do next. Now, how we actually implement that, I'm a big fan of Open Policy Agent myself. There's many ways to approach this, but it's a separate conversation. It's something I am definitely not qualified to talk about at the same level I'm at, or speaking about secrets and authentication. I see it evolving pretty quickly. That's really true. But I'm seeing that conversation more commonly out there of like, we're handling authentication this way and authorization this way. And how do we marry those together? That's evolving. That's an ongoing conversation. And in CNCF land, or CNCF mentality, would be spiffy to get you through the door, Open Policy Agent, say what you can do.
Interesting. But that doesn't say what the input to those open policy policies are. But I am going to agree with you and say that's a topic for another day. I just want to make sure you get a chance to have any last thoughts. So any last thoughts or upcoming events we should know about?
Thanks for asking. Actually, I'll promote my own website. I never, ever do this, but it's the easiest way to see where I am in the world. Just Dwayne-McDaniel.com. Yes, you can put a dash in the name of a website. That's what you've always been able to. But that has my upcoming tour dates and my conferences, my past conferences, and recordings of a few events I've gone, and the blog posts that I wrote up about those events. So if you want to track me, there's also links to the Get Guardian blog, where I write an awful lot. This is a Security Repo podcast, which you are actually on episode tomorrow, Mike. If you're watching this live right now, then the episode will come out on March 4th, where I interview you, and tables are turned. But I would say to anybody out there that's listening and you're thinking, do I have a problem with leak secrets? Do I have a plan for getting rid of moving away from long-lived secrets? And if the answer is, I don't know where to start by just scanning. I would highly recommend using Get Guardian. You use it for free as an individual. You can use it for free for open source projects. And if your team's less than 25 people touching code, it's completely free to use for code scanning forever. Just start there. Start with understanding where you have. Our local tool, GG Shield, is awesome for understanding what's on your machine, scan all your paths. I was horrified to find out some of the stuff that was on my machine when I started doing that, believe it or not. Stuff from like years ago I'd completely forgotten about, and folders that I haven't touched in 2 years had active secrets in there. But start having that conversation with yourself, with your teams. Like, how do we go from someone could infect my machine, grab my credentials, and then do something malicious, to someone has my machine, but the thing they were trying to do just didn't work because there was nothing to steal. They can't infect a pipeline if you can't get into it.
Awesome.
Let's leave it from there.
Yeah. Good advice. And I just want to announce quickly the next episode. Alex Weinert from Semperis. The topic is All Your Accounts Belong to Us, IDPs Under Attack. It sounds like where we started this conversation. But with that, I will say, Dwayne, thank you so much for being on the live stream. It's been a pleasure. So thank you, Dwayne. Thank you, audience.